The electrical system of the Fokker 100 comprises a 115-volt, 400 Hz three-phase AC system and a 28-volt DC system. This topic will cover the AC electrical system. We shall describe the sources of AC electrical power and its distribution to the electrical system. We shall describe the controls on the electric control panel and examine how the indicators are used to monitor the system. Finally, we shall examine the malfunctions of the AC electrical system and the procedures which must be followed to deal with them. The Fokker 100 has a 115-volt, 400 Hz three-phase AC power system. Power may be supplied from an external ground source, two engine-driven generators, or the APU-driven generator. External power may be supplied by an AC ground power unit connected to a socket at the right-hand forward side of the fuselage. The ground power control unit automatically connects or disconnects external power to the electrical system. Each engine drives an integrated drive generator, which consists of a generator and a constant speed drive, which ensures that the generator operates at a constant 12,000 RPM to produce AC power at a frequency of 400 cycles per second. A generator control unit connects each generator to the electrical system and automatically disconnects it in the event of a fault. The APU-driven generator supplies AC power both on the ground and in the air. The APU operates at a constant speed and therefore does not require a constant speed drive. The AC power sources are distributed to the electrical system through an automatic bus transfer system, which ensures an uninterrupted supply of power if one system fails. Normally, Generator 1 supplies AC bus 1, and Generator 2 supplies AC bus 2. Generator 1 supplies the essential AC bus, and the essential AC bus supplies the emergency AC bus. AC bus 2 supplies the AC ground service bus and the avionics transfer bus. AC and DC power are both controlled from the electric control panel, which is located on the overhead panel. The external power push button switches AC external power on or off and indicates whether external power is available, switched on or not available. The generator push buttons are used to switch the generators off or on and indicate their status. Each auto AC cross-tie push button is used to switch the AC bus transfer off for the selected AC bus and to indicate its status. The galley power push button is used to switch galley power off or on and to indicate whether galley power is connected. The essential and emergency power only push button is guarded and is used to disconnect all the buses from the system apart from the essential and emergency buses. The electric control panel also includes 3 digital display windows which are used to monitor the system. The rotary display selector is used to select which electrical buses or sources are to be displayed. 3 display push buttons are used to select whether load, voltage or frequency values are displayed. Now that we have described the AC electrical system, we shall look at its operation. When the batteries are switched on at the electric control panel, power is supplied to the emergency AC bus via the emergency inverter. This will be discussed in more detail in the topic on DC power. When external power is connected, the external power push button on the electric control panel indicates a white available light. When external power is available, power is supplied to the AC ground service bus, which supplies the ground service transformer rectifier unit, or TRU. The TRUs will be described in the topic on DC power. External power is switched on by depressing the external power push button. Now switch on external power. External power is now switched on. The available light is replaced by a white on indication. When external power is switched on, it supplies AC bus 1, AC bus 2, and the essential AC bus. AC buses 1 and 2 supply TRU 1 and 2, battery chargers 1 and 2, and galley buses 1 and 2. AC bus 2 now supplies power to the AC ground service bus and the avionics transfer bus. The essential AC bus supplies the emergency AC bus and the essential TRU. When the APU is switched on, external power continues to be supplied to AC bus 1 and AC bus 2, and the APU supplies power to the essential AC bus, from which power is supplied to the emergency AC bus and the essential TRU. When external power is disconnected, the APU supplies power to AC bus 1 and AC bus 2 and continues to supply the essential AC bus, emergency AC bus, and essential TRU. When generator 2 comes online, it supplies power to AC bus 2 and the emergency AC bus and essential AC bus. The APU supplies power to AC bus 1. When generator 1 is brought online, generator 2 continues to supply power to AC bus 2. Generator 1 supplies power to AC bus 1, the essential AC bus, the emergency AC bus, and the essential TRU. The APU is on standby. If the load is too high, power may be disconnected manually from the galley buses by pressing the galley power push button. Switch off galley power. When power has now been disconnected from galley buses 1 and 2, a white off light illuminates in the galley power push button. In the event of electrical smoke, power may be removed from AC bus 1 and AC bus 2 simultaneously by pressing the essential and emergency power only push button. Power will continue to be supplied to the essential AC bus and the emergency AC bus. Disconnect power from AC buses 1 and 2. Power has been simultaneously removed from AC buses 1 and 2. Only the essential AC bus and emergency AC bus are now energized. We will now examine the operation of the electric control panel displays. In this example, an external power source has been connected and is switched on. External power has been selected for display, and voltage has been selected as the display parameter. The center display window shows the external power voltage. If a bus or power source does not exist for a particular window, nothing is displayed. Therefore, in this case, the left and right display windows are blank. A different display parameter for external power may be selected by pressing the appropriate display button. Now display the external power frequency. With external power selected and the frequency display button depressed, the center display now indicates the external power frequency. If a parameter is not available for a selected bus or power source, dashes are displayed. For example, if the load button is pressed when external power is selected, the center window shows dashes. The selector is rotated to select alternative buses or sources for display. Now select AC bus 1, the essential AC bus, and AC bus 2. AC bus 1, the essential bus, and AC bus 2 have now been selected for display. Because load readouts are not available for these buses, dashes are shown in the windows. Now display the AC bus 1, essential AC bus, and AC bus 2 voltages. The voltage button is now depressed, and the voltages of AC bus 1, the essential AC bus, and AC bus 2 are displayed in the left, center, and right windows respectively. Generator and emergency AC bus readouts may also be selected by rotating the display selector and pressing the display buttons. As we have seen, Generator 1 and Generator 2 are each connected to the electrical system by a generator control unit. If Generator 1 or Generator 2 fails, the affected generator is automatically disconnected from the electrical system. In this example, Generator 2 has failed, and a Level 2 alert is presented at the flight deck. The left MFDU enunciates a fault in Generator 2. The right MFDU displays the procedure to be followed. AC bus 2 is now supplied by Generator 1. An amber fault light illuminates in the Generator 2 push button. If the generator's voltage or frequency are checked, the readouts will indicate that there is a fault. First, an attempt should be made to correct the fault by switching the generator off and then on again. Now switch off Generator 2. Generator 2 has now been switched off. It should now be switched on again to see if by resetting the system the fault can be rectified. Now switch Generator 2 on again. Generator 2 has now been switched on again. The fault has recurred, and the generator should now be switched off. Now switch off Generator 2. Generator 2 has now been switched off. If the APU is available, it should be started. The APU supplies power to AC bus 2. The alert for an engine generator fault is inhibited for the phases of flight shown in the table. If there is a fault in the APU generator, a Level 2 alert is presented at the flight deck. If the APU is currently connected to the electrical system, it is automatically disconnected. The left MFDU enunciates a fault in the APU generator. The right MFDU displays the procedure to be followed. First, an attempt should be made to correct the fault by switching the generator off and then on again. If the APU generator again indicates a fault, the procedure is to switch the generator off. When the generator has been switched off, a white off light illuminates in the APU push button. The alert for an APU generator fault is inhibited for the phases of flight shown in the table. If Generator 1 and Generator 2 fail, both generators are automatically disconnected from the electrical system. Battery power supplies the emergency AC bus only. With no AC power available, the MFDUs are inoperative. The standby annunciator panel indicates an AC supply failure. First, an attempt should be made to correct the generator faults by switching them off and then on again. If faults are again indicated in the generators, they should be switched off. If it is available, the APU should be started. The APU will supply AC buses 1 and 2 and the essential and emergency buses. There is no FWC inhibit for a double generator failure because this failure would normally render the FWC inoperative. The SAP AC supply light would therefore be the only indication, as SAP lights are not subject to flight phase inhibitions. Note that a fully charged battery will supply a minimum of 30 minutes power, including one APU start attempt. If there is a fault in the essential AC bus, emergency AC bus, or avionics transfer bus, a Level 2 alert occurs at the flight deck. In this example, there is an emergency AC bus fault. The left MFDU enunciates that a fault has occurred in the emergency AC bus. The right MFDU displays the procedure to be followed. The fault can be confirmed by checking the buzz voltage and/or frequency at the electric control panel. Now check the emergency AC buzz voltage. With the emergency buzzes selected for display and the voltage push button depressed, the left display indicates the emergency AC buzz voltage. Refer to the buzz equipment list in the Quick Reference Handbook for details of the systems which are inoperative. The alert for an essential AC buzz, emergency AC buzz, or avionics transfer buzz fault is inhibited for the phases of flight shown in the table. If there is an auto AC cross-tie fault, a level 1 alert is presented at the flight deck. In this example, there is a fault in the AC Buzz 2 auto cross-tie. The left MFDU enunciates that a fault has occurred in the auto AC cross-tie. The procedure to be followed is displayed in the right MFDU. An amber fault light illuminates in the auto cross-tie push button. The procedure is to switch the auto AC cross-tie off. Now switch off the AC Buzz 2 auto AC cross-tie. When the auto AC cross-tie is switched off, the cross-tie between AC Buzz 1 and AC Buzz 2 is inoperative. The alert for an auto AC cross-tie fault is inhibited for the phases of flight shown in the table. If there is an AC Buzz fault, a level 2 alert is presented at the flight deck. In this example, there is a fault in AC Buzz 1. The left MFDU enunciates that a fault has occurred in AC Buzz 1. The procedure to be followed is displayed in the right MFDU. In the event of an AC Buzz 2 fault, the right MFDU will be inoperative. In order to keep DC Buzz 1 powered, DC cross-tie should be switched on by pressing the DC cross-tie push button. A white on and flow bar indication illuminates in the DC cross-tie push button. DC buzzes 1 and 2 are now connected. If there is an auto AC cross-tie fault, auto cross-tie should be switched off by pressing the appropriate auto AC cross-tie push button. When the auto AC cross-tie push button has been pressed, a white off light illuminates in the push button. Auto AC cross-tie is now switched off. The Quick Reference Handbook should be checked for any additional procedural information. Refer to the buzz equipment list for information on the systems which are inoperative. The alert for an AC buzz fault is inhibited for the phases of flight shown in the table. In this topic, we described the sources of AC power on the Fokker 100. These are external power, 2 engine-driven generators, and the APU. We explained how the automatic bus transfer system maintains an uninterrupted supply of AC power to aircraft systems. We showed the normal distribution of AC power where generator 1 supplies AC buzz 1, the essential AC buzz, and the emergency AC buzz. And generator 2 supplies AC buzz 2, the AC ground service buzz, and the avionics transfer buzz. We also considered the priorities of power distribution when different sources were connected. We described the controls and indicators for AC power on the electric control panel and examined their operation. Finally, we examined the malfunctions of the AC electrical system, their indications, and the procedures for dealing with them.